So welcome back. As I mentioned in the last class, we discussed about uh, the introduction to image segmentation. How is it different from image enhancement, and what actually is the major difference? So as somebody has already answered, the major difference is the output of an image segmentation algorithm or procedure will be attributes rather than images that you get in image enhancement. Okay, so that is the difference. So let us go back to our discussions now. So is my OneNote visible?
Yes, sir.
So we started off with, in fact, the outline of the presentation, and also we tried understanding how is it different from image enhancement techniques like equalization or filtering technique like Wiener filter. And we also looked into the definition of image segmentation. So as you know, it divides into constituent regions or objects, and I explained with the example of a traffic okay, in fact, a road condition. And this, I think, I have explained it very clearly now. Now there are two different ways of doing segmentation. One is based on discontinuity, other is based on similarity. So you can see each one of them is opposite to one another. So here I am interested in how different the pixel values are, or what changes you have in the intensity. Whereas in the case of similarity, I just want to look at in what way they are similar, how close the pixel values are. Okay, of course we define a predefined criteria and then start partitioning the images. What do I mean by predefined criteria? Assume that I just want to classify satellite image into maybe roads, into vegetation, into buildings, into maybe mountain, etc. So you know every into water region. So water region would occupy some gray level values. Vegetation will occupy some gray level value. So what I do is I'll just predefine that criteria and start partitioning based on this criteria. So we will be discussing in detail about this in the later slides to come. Now let us try to understand some mathematics behind this. Okay, so now before going to this, let me just show you an image here. Okay, what is the image you are seeing here?
It's an image of different types of fruits,
Yeah,
including
so
apple, banana.
correct. So what I'm trying to do is I assume that you have been asked to probably identify the different types of okay. This is a synthetic image. You will not have a real scenario like this. Okay, this is a synthetic image, but it will definitely help me to explain the concept. So uh, can anybody tell me if I want to segment and identify apple, identify banana, identify orange, and identify guava here, what technique I'll do? So, what could be a better way of classification? Okay. How did somebody spoke? He said banana dash dash dash. So how did you know that it is a banana? What feature you used? Can somebody tell me? It's a simple, straightforward question. Please respond.
Sir, if we will choose color of the fruits,
Exactly. Yeah. I think somebody is telling. Okay, let me just see. I will be happy. So shapes, color is what Rakshita is telling. Color and second one is shape. Yes. Okay. So in this case, in this particular example that you see, uh, I'll start with color. It has some issues which we'll discuss later, but I'll start with color. So all of you know, if I, when I read this as an image, I think it's nice to read such images and start seeing the color values here. So this value, this will have some color. So in the RGB, red, green and blue format, so it will have some numbers, okay, some numbers, 0 to 255 in each one of them, okay. Suppose if I convert this into say gray level image, if I convert it into gray level image, then probably I will have one gray level value, okay. This is a color image, so I don't know what in fact if I read it in MATLAB it would be nice, but I just for want of time will not go for it. So this is only an assumption. So R, let me just use some numbers. So let me just assume that the R value is A and G value is B and say B value is C, R, B, A, B, C. Okay. These are the values of red matrix, blue matrix and green matrix and blue matrix. Definitely this will have a different value. So let me just take that as A1, B1 and C1, and this will definitely have a different value, say some A2, B2, C2, and of course Apple will also have some different value. So A3, B3, so some numbers. So now I'll use this criteria and go to a particular part and try to see whether all the pixels are having this range. For example, if all the pixels are having this range, so which means that I can now segment this. This will be one region now. So let me call this as region R1. Okay. Now I'll use some other color for the orange fruit and let me call this region as R2. And of course this region, of course it may also include the leaf there, but let us not worry about it, R3. And this region is R4. This is R4. Forget about this leaf region. It's only there in the image. It's a synthetic image. I'm not bothered right now. So you know R1, R2, R3, R4 are the regions. What is R1? R1 is a region of all the gray level values which is having this value or very close to this value. Okay. R2 is a region which has got its gray level values. In fact, in the three matrices, RGB matrices, A1, B1, C1 are very close to it. Similarly, R3 and R4, and the rest is R5. I can just call the rest of the white region in the background is R5. Okay. Now, I think it would be clear to you to understand this mathematics. So let us now try to understand this math. Okay. Now what it says is let R represent the entire spatial region occupied by an image. So this whole thing is R, which is let us assume that it is some say 400 cross 500 image. Okay, this is R. It is the entire region. Entire region means entire image that you are talking about. This whole thing. Okay, so that is R. Now what image segmentation does is it is a process of partitioning R into n subregions R1, R2, Rn. Okay, so you have seen that R1, R2, R3, R4, R5. So in this case n is equal to 5. So it is subdividing into 5 regions. So in this case 5 regions such that, now what is the condition? If you take the union of all these regions, I should get back my image. That means my segmentation should be complete in all respects. Okay. If you take see if you take I'll go to this. So for example, if I take union of R1, R2, R3, R4 and R5, I should get back the image. So obviously, you know, R5 is this region. Maybe I can just show it in, okay, something like this. So whatever I am marking in red now, this hatched portion is R5. So obviously, when I take the union of all these uh, subgroups or the regions, I'll get back R. Okay, I hope this point is clear to you. Then what is speciality of each of this region? Each of this region is a connected set. What do you mean by connected set? If you look at these values, they will have the value A, B, C. Of course, let us assume that all of them have got the same values. So when you just use a connectivity and use that value, so your V value, if you define it, remember we discussed about labeling of connected components. So if you define V value for this as A, B, C, obviously all these which are in this region, in this banana region, they will be connected. They all will have the same value or very close to it. If suppose if the color slightly changes, we will still connect them. So that is the meaning. Each region is a connected set. Connected set means with the criteria V that you have given, it is connected, and this is true for all of them. Okay, that means every pixel in this particular region, they are connected. Similarly, every pixel in this region, they are connected. Every pixel in this region, they are connected, and similarly this. So they are all connected, and of course every pixel in this region, in the background, they are connected. See, this is white region, so they are all connected. Connected means they will have same or similar values. That is the meaning of connectivity, which we have discussed in first chapter itself. Now the third point is the intersection of these regions, as long as I not equal to j, is a null set. That is also true. The R4 and R5 intersection is a null set. There is no common factor. R1 and R5 is a null set. R1 and R2 is a null set. So I think it's self-explanatory. The intersection of them is a null set. That means there is no intersection among these regions. They are just disjoint. Now we have a very important step here. Q of Ri, this Q of Rk is actually called a logical predicate. Predicate means it's a condition that we define. Okay. For any region Ri, this is true. What do I mean by that? For example, if I take a specific region, say R1, what I say is all the values, all the gray level values in this region should satisfy a condition that it is equal to these values. So that is a condition. So this has to be true for the entire region Ri. Okay, because this is a property to be satisfied in a segmented region. It all the gray level values or all the values should be same. Okay. Another important point is the union of Ri and Rj. Suppose if I just take Ri and Rj for any adjacent regions. What I mean by that, for example, R4 and R5, they are adjacent. Okay, R4 and R5, they are adjacent. So the union of that, okay, will be false. That means the condition will not satisfy. See, because when I take the union, definitely, of course, I will have this and this, but the condition cannot satisfy for this because this has got a different color combination, this has got a different color combination. So you cannot expect it, when I take a union to satisfy the condition of your predicate, whatever you are defining. Okay, so two adjacent regions must be different in the same sense of predicate. So when I take these two and when I define the color combination, R4 will have the color combination A3, which one I have used? Yeah, A3, B3, C3. Whereas R5 will have a different color combination, so the union will be a false. Okay. So any doubt in this? I think it's self-explanatory, and I hope with this example it should be clear. But if there is any doubt, please let me know. Otherwise, we'll go to the next slide. Any doubt?
No, sir.
Okay. So let me just go to the next. Okay. Yeah. Now segmentation of monochrome images is based on properties of intensity values. All of you know that. Okay. So for example, assume that I have an image and the gray levels are something like this: 11, 12, 15, 16, 100, 110, 120, 130, 140, 130. This is say some 200, 200, 250, 225. So this maybe say some 0, 1, 2, 3. Let us just take this. Now assume that this is a monochrome image. Let us assume that we want to segment it. Okay, so we will use the condition like this. Say the first condition is the range of values v1 equal to say some 10 to 20. I want to group all of them as one segment, and I want to group all the values in the range say some 100 to 180 as one group, and I want to group say all the values from 200 to 255 as third group, and fourth one maybe from 0 to 9. Suppose if this is the case, all of you know this will be one segment. Of course I have intentionally taken them to be like this. This will be one segment, this will be one segment, and this will be one segment. So based on the intensity values, so the intensity values here are almost or in the range of your condition that you have given, the predefined criteria. So that's why this is one segment, this is another segment, third and fourth. Okay, now edge based segmentation is the approach. I think this I have already explained, but let us just relook at it. It uses the discontinuity, and here the assumption is the boundaries are sufficiently different from each other. For example, in this case only, just observe this difference between these two pixels. One is 15, which is a darker pixel, other one is 200, which is a bright pixel or white pixel. So definitely there is an edge between these two pixels. So you have an edge here, you have an edge here. Here also 12 to 120 you have an edge, 10 to 100 you have an edge. So you can see that edge based will look at these neighboring pixel values and take a decision whether there is an edge or not, and based on that it will say yes, this is one segment and this is second segment, and so on and so forth. Whereas region based, it actually looks at similarity. What it does is so as I said, no, it goes to a particular pixel, say 225, and look at the neighbors. If I use 8 connectivity, it will look at all these neighbors. Okay, so it will look at all these neighbors. Now you can observe that 200 and 225 are in the same range, so these two are connected. 200 and 200, they are connected. These two are connected. I think connectivity is discussed in detail. So these two are connected. So which means that these are all the connected components. So I just start with a seed point like this, start moving around and start grouping all of them, and then say this is one segment. So it uses the similarity. See, here we are seeing the edge here and then taking a decision. Here we start with a seed point and start growing it. So that's why it's called region growing also. So you just start increasing this area and go up to that region where the color combination is same. That means the predefined value. I hope the concept is understood. A very good example is given here. So just observe the first image here. You also read the label here. So this is an image containing region of constant intensity. You know, this region has got some intensity value, and this region has got some other intensity value. Maybe I think if I'm uh, okay giving a number, maybe I think this could be somewhere around 120. Maybe this could be somewhere around 180. Okay, roughly I'm just taking a guess. Okay, so all these values are 180 and all these values are 120. So when I want to do edge based segmentation, just pass this through a high pass filter. You know how to detect edges, we have discussed in the last class. Pass it through a high pass filter, this is what you get. Okay, so I get a clear boundary here. Now anything within this boundary, you just make it as white, so that is one color. Anything beyond this, you make it as black, that is black color. So you have just segmented. If your interest is this, you can call this as foreground now, because this is what you are interesting. This could be your fruit that you are trying to detect, maybe, of course, an example I'm taking, and this will be the background now. This is how edge based segmentation works. Okay, now suppose if I just try to do a similar thing, what would happen, I'll tell you. Now assume that you have an image like this. This is an IC image. See the okay. In fact, it's also called textured image. So it is an image containing textured region. Okay. So I hope you can clearly see that there are some variations here. So you have a texture in this region. Hope on your screen also it is visible. This region is not smooth. I cannot say the values is 180. The value could be 180 or maybe something like probably it could change from say 100 to 180. I don't know. Anyway, the values are perturbing there. Okay, it can even go below 100 also. I don't know. Okay, of course this region is smooth, but this region it is textured. So in this case, if I again use the same edge, okay, maybe a high pass filter and pass it through a high pass filter, what will happen is this E. So just observe this E here. Um, when I do this computation of edges, you could see that within this region, you could see that lot of variations are seen. So now I cannot just okay say anything above this value make it white and anything below this value make it black. In this case it could be easy because you have a clear boundary here and within that all the values are same. Whereas here suppose if I just makes the values as white and black, what you will get actually is you will get lot of white pixels within this also, a lot of black pixels within this also. So you may not get such a smooth region. So in this case what we do is just go to this region, define a range. For example, all pixels within 100 to 200 or whatever value. You have to decide this. This is why we say predefined criteria. And then all these values between 100 to 200, I'll make it as 255. And all the values below, okay, less than this, I'll make it as say 0 or 10 or whatever it is. So you can observe that the segmentation is done. Okay, so I hope you understood the difference between the first one, which is the edge based segmentation, the second one, which is the region based segmentation. In this case we just use the edge and made the segmentation, but in this case we actually used the region here and tried defining a predefined criteria and started growing that for the entire region. Okay. Yeah, I think uh, probably this is where we can stop for today. Uh, thank you for attending the class. I'll